Hello guys and welcome to another presentations of the Vigilant Society of Engineers online engineering platform. This time we'll be presenting to you a programmable logic controller which can be used for process automation. Please don't forget to like, share and subscribe to our platform. Well, an introduction to a programmable logic controller such as this one as a Siemens. The Programmable Logic Controller is an industrial computer that has been ruggedized. PLC computers help us to automate processes that involve input-output operation. PLC operation was modeled from old relay technology that is now incorporated into a PLC device. Now, the history of PLC unit. As you know, PLC was first discovered by a gentleman who goes by the name of Dick Morley. He's the first person to have invented the first PLC unit, and the first one was named the Mothercon 084. Which he has invented for General Motors in 1968. The applications of PLC device entails assembling line processes, machine operation, robotics, and so much more. PLC is commonly used in controls of manufacturing processes. Reason why so many people are obsessive about PLC unit is their high reliability and also the ease of programming. The PLC program is somewhat easy to facilitate diagnostics when there's any issue as it relates to the automated process. And also, the automated process helps to defer repetition, so as making the process simple and easy. Now, when it comes to PLC unit, there are two different types. And that is the fixed PLC device and the modular PLC units. With the fixed PLC device, that is already been set by your manufacturer. He determines the amount of input and the amount of output. For the modular PLC devices, however, the customer can acquire as many output and as many input, so as he choose. Most PLC devices require software. The PLC software is a tool used to program a PLC device. PLC programming software involves writing instruction sets that is going to tell the PLC unit the automation process. There are 5 languages of the PLC device. This language involves function blocks, instruction or rather structural text, ladder logics, instruction lists, and finally sequential chart. What do I need to make a PLC work for me? Definitely the PLC unit itself. Secondly, we all need the power supply And thirdly, we need the input devices. So let's talk about input devices. Input devices of PLC unit involve analog device and digital input device. An example of an analog device entails a pressure sensor. It may also be a temperature sensor, alright, and a digital input incorporated, or otherwise could be a limit switch, a level switch, right, and partly an analog device is also a speed sensor, right, and a proximity sensor, right. So the input devices of a PLC can be both analog or digital, alright. So in that list that is highlighted, there's a combination of analog input device and digital input devices. Now, what are the other part or outputs of the PLC devices? So a PLC device requires analog input. It also requires analog output devices or digital output devices. Alright, so the device can be one of, as indicated in this section. So it could be a motor, it could be an indicator light, and it could be a, alright. So with the PLC unit, we have to consider what we're trying to accomplish. So what do we accomplish with PLC? Just about anything we choose or desire, right? Since the automation process involves manipulations of the input and output devices within the field, we need to provide addresses to these devices, and so when the PLC call upon them, it can read each individual input or output as an addressable device, and so it is able to manipulate these devices by the addresses that is assigned to them. Take for example, an address could be a letter and it could be a number. So an address of the PLC unit input could be I1, it could be T1, alright, and so forth. And the output can be Q1, Q2, Q3, etc. Right? So when we're able to address each input or output, we're able to monitor the PLC operation. So to monitor this sequence or rather addresses, we gonna use the assignment within a PLC ladder logic program. Alright, so the ladder logic is one of the programs that can be used for the PLC unit. Alright, so the ladder logic here involves different rungs, which include the input and the output devices, alright, assigned by the I's and the Q's. Alright, we also incorporate different ladder symbols, such as a timer in this diagram. So we can use different ladder symbols in combinations to provide the input and output operations of the PLC unit. Alright, so we're going to demonstrate a PLC automated process. right? So with this process, we have a momentary push button, we have a microcontroller, and for the microcontroller, which is a PLC unit, we have tied to them that same push button along with output devices of indicator lights, lamp, and a fan. Alright, so for the PLC unit, we need a power supply. And the power supply, we need 24 volts, right? Since we are accustomed to receiving 120 volts from our incoming power supply, we got to reduce that value to 24, drive our PLC unit. And on the other sections of the PLC unit, we have relays, which is used to isolate the higher voltage supplies and the lower voltage supplies, so as to make our PLC system isolated from the high voltage supply. Okay guys, so here goes. We're gonna give you a presentation of the PLC unit in operation, and it goes as follows. Okay guys, so we have this PLC system programmed for input and outputs of push button, lamps, and indicator lights. Alright, so the PLC unit utilizes 24 volts in operation, and once powered, it is able to do the operation that it's somewhat programmed for. Alright, so just before we had downloaded the software to the PLC, and then after which we start the process. Alright, so the device rather holds the program, and that program is able to provide the control operation. So one of the things that we're able to do is to change the indicator lights across the PLC unit from light 1 on the right all the way to light 4 on the left. Alright, so beside those lights we have an indicator lamp, and we also have a fan. Alright, so the lights and the fan is just an example of one of those actuators that we can use on the system. Alright, so it depends on what you're trying to accomplish. You can do just about anything in this process. Alright, so because you're looking for accomplishing a specific task, you'd use whatever field devices that you wish to choose. Alright, and also that may include the input and the output. Alright, so the input field devices could be sensors of temperature, pressure, flow, limit switch, etc. And the output can be motors, it could be lights, it could be fan, right? It could be so many different types. Alright, so based upon the process that you want to control, right? This is such the perfect device that you can choose. Alright, so that is how the PLC device is able to work altogether. Okay guys, thank you for watching. Please like, share and subscribe. You may visit us at www.vigilantsocietyofengineers.com for more information on PLC unit and other electrical systems. Thank you.